sound.
Alright guys, in last lesson we learned about electrolytic cell and also electrolyte, yeah? So we haven't go deep about electrolytic cell, we just cover a very basic thing, okay? So let's do a very quick recap before we continue with our lesson, yeah? Alright, so electrolytic cell, also known as electrolysis, okay? So if you see electrolysis, actually it has the same meaning as electrolytic cell, yeah? So when we come to electrolytic cell, make sure we know the function, what electrolytic cell do for us. So electrolytic cell, we are trying to use electricity, yeah? We want to use electricity to break down a chemical compound, yeah? So we use electricity to break down a compound, okay? So example, okay, we will use electric to split sodium chloride, yeah? Sodium chloride, we will learn in a short while how to use electric to split the sodium chloride to form sodium, metal, and chlorine gas, okay? So one more example, we can use electrolysis to break down aluminium oxide. So if we have aluminium oxide, we can use electric to break it down. So when electric break down aluminium oxide, we will get aluminium metal and we will get oxygen gas, okay? So that is what electrolysis do. Electrolysis, we are using the electric to break down a chemical compound, yeah? We use electric to split a chemical compound, yeah? So this is something we touched in the last lesson, just a quick recap, okay? So what else we learned? We also learned about energy change, we also learned about energy change. So electrolytic cell use electricity, so we must start from electrical energy, yeah? We need to start from electrical energy. We use the electric to break down a chemical compound, yeah? We use electric to break a chemical compound. So chemical compound, we have chemical energy, yeah? So electrical energy convert to chemical energy, yeah? So this is the energy conversion in electrolytic cell, yeah? So we have two types of electrolytic cell that we will learn. So we will learn electrolytic cell. There are two types. Okay, the first type we will learn is molten. So molten. Okay, so today we will focus and learn everything that we need to know for electrolysis of molten compounds. So in this lesson, our main focus is to learn electrolysis of molten compound, how to break down molten compound by using electricity. Okay, so let's do a quick recap. So what is molten? So molten we learned in last lesson. Molten stand for melted, yeah? Molten stand for melted, okay? So how to get molten form? So we just go to heat a solid. We take a solid, we heat a solid, okay? Alright, until the solid is melted, until it is melted to form liquid. Okay, when we have a solid, we heat the solid. When the solid fully melted, it forms a liquid. The liquid that we get is called molten. Okay, example, we have some let's say we called it as aluminium oxide. So when aluminium oxide, we heat it, aluminium oxide melted. When the aluminium oxide is melted, now we have molten aluminium oxide, yeah? So that's it. When we heat a solid, until the solid fully melted become liquid, so then the liquid we call it as molten. Okay, so what else we learned in last lesson? Okay, we also learned about setup apparatus. Okay, the setup apparatus, okay, for the electrolysis of molten. Okay, so how you do the electrolysis of molten. Okay, so electrolysis of molten, since we want to do electrolysis, we want to use electricity. So when we want to use electric, so we must get electric from somewhere. So we use battery. So this is battery, or we call dry cell. Battery also can call dry cell. Okay, so the battery will supply the electric to us. The battery connect to wire. This is electric wire. So the electric wire connect to two pieces of carbon electrode. Okay, we connect the wire to two pieces of electrode. Okay, we will learn more about electrode later on. Okay, so for now, these two electrode, you don't need to purposely memorize. I just want you to know that we have electrode and it's made by carbon. Yeah, we have carbon electrode, no need to memorize. Okay, so this carbon electrode, they need to immerse into some liquid. So this liquid is, we call it as molten. Okay, so this is the liquid in a molten form. So this is the molten compounds. Okay, so when we take the solid and heat it up, we get the molten compound, and this molten compound, it is our electrolyte. Okay, this is our electrolyte. If you don't know what is electrolyte, please refer back to last lesson. Please refer back to the last lesson. And this is crucible. Okay, we use crucible because we want to melt a substance. To melt a substance, we need to heat it up. So glass cannot tahan high temperature, so we don't heat using a glass. We heat using crucible because crucible is made of ceramic. Okay, crucible is made of ceramic. Ceramic can withstand very high temperature. Yeah, ceramic can withstand very high temperature. Okay, we learned this in your Form 4 Chapter 8. Form 4 Chapter 8, we learned that ceramic can withstand, can tahan very high temperature. Okay, so now, okay, before we continue to learn some technical thing, before we continue to learn some technical part of the electrolysis, so I will share with you some of the common question, a popular SPM question. This is a very popular, this is a popular SPM question. Okay, so this is more on a theory. This question is actually related to your SPM Form 4 Chapter 5. This is related to your Form 4 Chapter 5. Form 4 Chapter 5, it's called chemical bonding. Yeah, you learn about the bond. Okay, so if you need to, you might need to revise back. Okay, if you forget already, you might need to revise back. Okay, so even you don't know, never mind, I just give you some idea only. Alright, so now here we have two picture. Okay, this is the first picture we have. So we have battery, we have two pieces of electrode. So here I put a bulb. Okay, this is a light bulb. Okay, and then here we put the molten thing. Okay, here we have the liquid molten and we heat it. Yeah, okay. Alright, so sorry, this is without heating first. Okay, this is without heating. So we don't heat it first. Okay, we don't heat it first. So this is solid. Okay, here we put some solid. Okay, inside here we have solid. Okay, lead to bromide. Okay, we have solid lead to bromide. So don't memorize the name here, the name of the chemical substance, no need to memorize. Okay, so here what you can see is that, okay, the bulb here does not lights up. Okay, the bulb does not lights up. Okay, so now, okay, let me go for another diagram. So I copy this picture. Okay, so this picture I put here first. So I copied it. Okay, so here I paste it. Okay. Okay, so here this one, everything is the same. The only difference is I heat it here. I heat it up. So when I heat it up, so it's fully melted. So when it's fully melted, I got some liquid. Okay, and when it's liquid, I call this as molten. Okay, this is molten form. So different is this. Okay, when it's solid form, you can see here. Okay, you can see here the bulb. Okay, doesn't lights up. Okay, the bulb doesn't or does not lights up. Okay, the bulb does not lights up. Okay, here when you use molten, you can see the bulb now lights up. Okay, now the bulb actually lights up. Okay, so I draw and show you the bulb lights up like this. Okay, okay, all right. Okay, so this is a very common and popular question in SPM. So the question will ask you this. Okay, so here we have total 2 questions. So 2 questions here. Question number 1, why, okay, when solid lead to bromide? Why when solid lead to bromide is used? When we use a solid lead to bromide, the bulb does not lights up. Okay, so this is the question. Why when we use a solid lead to bromide, so the bulb does not lights up? Okay, so here we need to know the concept first. Okay, when we want to how to think, how to solve the question. Okay, so whether the bulb got lights up or not, it all depends on whether you have electricity or not. Always remember this. Okay, if the bulb lights up means what? Got electricity. Okay, that's why the bulb lights up. If the bulb doesn't lights up, okay, if today the bulb doesn't lights up, means that there is no electricity. That's it. Okay, if you want to have the lights up, if you want to have the bulb to lights up, you need to have electricity. If the bulb doesn't lights up, means there is no electricity. That's it. Okay, so when we want to explain about electric conductivity, we only have 2 choices. We can use free moving ions to explain, or we can use free moving electron to explain. Yeah, we can use free moving ion and free moving electron to explain about electric conductivity. Because if you want to conduct electric from point A to point B, okay, if you want the electric to flow from point A to point B, you need to have charge carrier. Okay, you need to have charge carrier. Charge carrier means somebody to carry the charge. Okay, you need somebody to carry the charge. Okay, so the charge carrier can be ion or electron. So today, if you have ions can carry the charge. Okay, it can carry the charge to move from one point to the other point. Then it can conduct electricity. If you don't want to use ion, you also can use electron. Electron also can carry the charge and move from one point to another point. Yeah, so always remember, if you want to conduct electricity, you need to use free moving ion or free moving electron. And most importantly, when we should use free moving ion, when we should use free moving electron. We use free moving ion when we want to talk about electric conductivity of electrolyte. Okay, when we have electrolyte can be acid, electrolyte can be alkali, electrolyte can be your ionic compound. So when you want to explain why acid can conduct electricity, why alkali can conduct electricity, why ionic compound can conduct electricity, we use free moving ions to explain. We use free moving electron to explain electric conductivity for conductor. So today, if you want to explain why conductor can conduct electricity, then we use free moving electron. In SPM, the conductor is always a metal. So if you want to explain why metal can conduct electricity, we don't use free moving ions. We use free moving electron. Okay, metals can conduct electricity because of free moving electrons. Electrolyte can conduct electricity because of free moving ion. That's it. Yeah, this is a very important concept. So now we have lead 2 bromide. So lead 2 bromide, what it is? Lead 2 bromide, lead is metal, bromide is non-metal. So when metal combine with non-metal, this is ionic compound. So when you come to ionic compound, you want to explain about electric conductivity, you must use, okay, free moving ion to explain. So we need to use free moving ions concept to explain about electric conductivity. Okay, now look at here. So in solid form, what is the problem? Ionic compound, they have ions, they have charge. Ionic compound, you have charge. Okay, so let me show you a picture first. When you have picture, you can imagine better. Okay, all right. So when we have the solid form, okay, in solid form, I want you to see a diagram like this. Okay, in solid, okay, how to draw solid? Solid, we have something closely packed like this, right? Solid, all the particles, they are very close to each other. Yeah, so let's say this is Pb2 plus, this one is Br minus, this is Pb2 plus, this is Br minus, and so on. Br minus, Pb2 plus, okay, Br minus, Pb2 plus, and so on. Okay, so let me finish this one first. Okay, so in solid form, okay, all right, everything is close to each other. Okay, everything is close to each other. Okay, they are very close to each other. So you can see this in solid form. Okay, okay, so everyone is close to each other. Okay, all right, and then in between them, they have, okay, they have a attraction here. In between the ions and ions, there is a force of attraction. So positive and negative, different charge, they can attract together. Yeah, opposite charge, they always attract together. So these red color things is something we call electrostatic force, and we learn this in your form 4. Yeah, we learn this in your form 4. Okay, this is electrostatic force. Okay, so remember, when you have a positive ion and you have a negative ion, opposite charge will attract. So opposite charge, they will attract. Okay, and this attraction, it's called electrostatic force. Okay, so electrostatic force is the force of attraction between opposite charge. Okay, so in solid form, all the ions, they are very close to each other, so they are attracted by electrostatic force. So when there is electrostatic force, you can imagine they glue together. So this ion glue with this ion, glue with this ion, glue with this ion. When all the ion, they glue together, they cannot move. They glue together, they cannot move. Okay, or you can imagine this. Okay, you can imagine this. Okay, this is solid form. Okay, or if you want, you can imagine something like this. Okay, so in solid form, all the ions, they stick together like this. Okay, this is a positive ion, this is a negative ion. So there is a force of attraction, they glue together. So this force of attraction, you can imagine, they hold their hand together. Yeah, they hold their hand together. So here is another ion, so they hold their hand together again. Yeah, this holding hand here is your electrostatic force. So when they hold their hand together, so they stick together by electrostatic force. Okay, and this electrostatic force, let them stick together so they cannot move. Okay, so that's it. Okay, so how are we going to put this in words? Okay, how are we going to use some words to explain? Okay, so you can explain something like this. So you can say, in solid form. Yeah, in solid form. Okay, this is the answer you can write. In solid form, so you can see all the ion, they cannot move. So the Pb 2 plus ions and also the Br minus ions. Okay, all the ions, they are arranged in a very orderly manner. So you use this. They are fixed. Okay, they are fixed. They cannot move in a lattice structure. Now, this word lattice is something new for you. Okay, so what do we mean by lattice structure? Lattice structure means that they are closely packed together like this. Okay, this one, when you squeeze together, this whole thing is called lattice structure. Yeah, this is called lattice structure. Yeah, all right. So all the ion, they are fixed. Okay, they cannot move in the arrangement, repeated arrangement, which is called lattice structure. Yeah, all right. So when the ions, they are fixed, okay, so means what? Okay, and one more thing, okay, they're not only fixed, all the ions, they are attracted. All the ion now, they are attracted by very strong force. This force is called electrostatic force. Okay, they call it as electrostatic force. Okay, so when the ion, they are attracted by the force, and when they are fixed at one position, which means that the ion cannot move lah. Okay, you see this fella, this guy want to move, cannot move. Why? The electrostatic force is holding it. So when this guy want to move, this guy is pulling. So this guy is pulling the hand. So everyone pull their hand together, no one can move. So when no one can move means what? You have no free moving ion. Huh? So the ions now cannot move freely. Okay, so when the ions cannot move freely, they cannot carry the charge. Okay, they cannot carry the charge. So ions cannot move freely to carry the charge. So when you don't have the free moving ion, yeah, when you don't have somebody to carry the charge for you, so you cannot conduct electricity. So therefore, okay, therefore your solid lead to bromide cannot conduct electricity. So when you cannot conduct electricity, that is the reason why the bulb does not light up. Okay, this is why the bulbs does not light up. Okay, because there's no electric. Why there is no electric? All the ions, they are in the fixed lattice position. They are in a fixed lattice structure, and all the ions, they are attracted by a strong electrostatic force. When the ion now glue together by the electrostatic force, they cannot move. The ion cannot move. When the ion cannot move, they cannot carry the charge. Okay, so this answer seems very long, but if you fully understand it, it's not very hard. Yeah, if you fully understand it, it's not very hard. Okay, so this is a very popular question in your SPM that you should know. Yeah, this is very popular in your SPM. Okay, let me put it in box here. Okay, so another one questions which is quite popular as well is this. Okay, so let me show you another one popular question. Okay, so let me copy this. Okay, I paste it here. Okay, all right, so another popular question which they can ask you in your SPM is this. Okay, why when molten, okay, why when we have molten lead 2 bromide is used? So when we use the molten lead 2 bromide, now the bulb can lights up already. Now the bulb lights up. Okay, so why when molten the bulb lights up? Okay, in solid cannot. Okay, so same thing, let me show you the picture. Okay, so just now we already see the picture for solid form. So in solid form, as you can see, there is electrostatic force here. Okay, there is electrostatic force. Okay, so let me copy this diagram to here first. Okay, just let me copy this diagram. Okay, okay, so in solid form, So all the ions cannot move freely and they are attracted by electrostatic force, okay? Versus what happened when now we have molten form, okay? So now when it's molten form means melted, okay? When it's melted. So when it's melted, what is happening? Okay, when melted, what is happening? So when melted, when we melt the substance, we heat it. When we heat the substance, we are breaking the bond, okay? We are overcome the force. So when we heat the substance, the bond here are broken, the bond here are broken. So when the bonds are broken, so now they not stick together already. So let's say Pb2 plus is here, Br minus is here, 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 let's say, okay? So now you see they no longer stick together. So they don't have the force already. So this force is already broken, okay? They're already broken here. So no more force here, okay? So when no more force, okay, so you can imagine this, you can imagine the same picture we have just now, okay? Just now the picture we have. So this one, I just copied it, okay? Just copy this picture again. Okay. Okay, so okay, so just now solid form, we imagine them like all the ions, they are holding their hand, yeah? All the ions, they stick together, they're holding their hand. So they're holding their hand because of electrostatic force. So when there's electrostatic force, so the force let them stick together. So when they stick together, they couldn't move. Okay, so now when we come to molten form, so when we come to molten form, so the force it's overcome, yeah? So the force is overcome. So when the force is overcome, you can see here, all right? So break here, break here. So when we overcome the force, okay, so now all the ions, they are free already. All the ions, they don't hold their hand together already, yeah? So no more electrostatic force, okay? So now, okay, you can see no more electrostatic force. So when now they didn't hold their hand together, so all the ion now were able to move freely. So now if this guy want to move, can or cannot? Can, because no one is pulling this guy, no one is holding the hand. So this guy can go any place, okay? But just now, let's say this guy, can you move? Cannot, because when this guy want to move, this fella will pull. This fella will pull the hand. So when this fella pull the hand, cannot move freely, yeah? So this is the one. So in solid form, all the ions, they arrange in the lattice structure, and all the ions, they attracted by electrostatic force. Then the ions cannot move freely. But when you come to molten form, we heat the substance. When we heat the substance, the electrostatic force is overcome, okay? The electrostatic force is overcome, no more force. So when all the ion, they are not pulled by any force anymore, so all the ions, they can move freely. All the ion now can move freely. When the ion can move freely, they can conduct electricity already, okay? So now you can see this ion can move, this ion can move, so they can conduct electricity already, okay? So now how to explain in words like this? How you use the words to explain? So you can say in molten form, okay? You can explain like this. In molten form, okay, so the electrostatic force, okay, so the electrostatic force between, okay, just now we have electrostatic force between the ion, so the electrostatic force between your ion. So what is our ion? Okay, Pb2 plus and Br minus, so Pb2 plus ions and also the Br minus ion, okay? So the electrostatic force between the ions, okay, is overcome, okay, overcome. So no more electrostatic force already. When no more electrostatic force, now the ions, they are able to move freely. Now the ions, they can move freely. When ion can move freely, they can carry the charge. Okay, when ion can move freely, they can carry charge. So when they can carry charge, they can conduct electricity. So therefore, okay, therefore, conclusion, molten lead to bromide, molten lead to bromide, able to conduct electricity. Okay, therefore they can conduct electricity. Okay, so when they can conduct electricity, that is why you see the bulb lights up. Okay, so this is the theory. Okay, this is a very important theory. In solid form, ions cannot move freely. Why? They are attracted by electrostatic force and they are at a fixed position. So they are fixed, they cannot move. Okay, in molten form, the ions can move freely. Why? Because we don't have the electrostatic force anymore. So we don't have electrostatic force anymore. So when no electrostatic force, all the ion now they can move freely. They can move here and there. When the ion can move freely, so they can carry the charge and we got electricity already. Yeah? So that is the logic. Okay? So now we already covered the theory. We already covered the theory for the molten. So let's go for the technical part. Okay? So now, alright. So let us start with the technical part. Okay? Now we will do the technical part. Okay? For electrolysis. Okay? I'll show you what is the technical knowledge that you need to know for electrolysis. Okay, so this part I will go very slow, okay, to make sure that you can fully understand, okay, because if you don't get the idea, it can be very confusing. Okay, so now let us start with the technical part. Okay, all right, so I will show you some strategy first. Okay, I'll teach you the strategy, what you need to know for electrolysis. Okay, I'll teach you the strategy one by one for the electrolysis first. Then we will use a few examples. Okay, we will use a few examples to demonstrate. Okay, I'll use a few examples to show you how it works. Okay, so let me talk about the strategy first. Okay, what you should do whenever you have electrolysis question. So follow my step. Okay, follow my strategy step by step. Okay. So first of all, whenever you have electrolysis question, the first thing you need to do is you need to label the positive and negative terminal. Okay, you need to label your positive and also your negative terminal. Okay, positive and negative terminal in electrolysis is actually decided by battery. Okay, so this is decided by your battery. Okay, battery also can call dry cell. Okay, you can call battery as dry cell. In BM they call it as cell curing. In BM they call it as cell curing. Okay, so now we use the battery to decide whether it's positive or negative terminal. Okay, all right, so we don't need to use the E0 value. The E0 value, that is for Voltaic cell. So for Voltaic cell, how we decide the negative and positive terminal, we check the E0 value. The one with the more negative E0 value will become negative terminal. The one with the more positive E0 value will become positive terminal. That is for Voltaic cell. Electrolysis, totally different. Okay, electrolysis, we just need to check battery like this. Okay, so if they give us a battery, so we can just check, okay, who is positive, who is negative terminal. The longer side of the battery, it's positive terminal. The shorter side of the battery, it's negative terminal. That's it. Yeah, all right. So sometimes they can reverse it. Okay, battery not necessary they must draw the long one first. No, they can draw a shorter one first, then a longer one. Shorter one, then a longer one. It's okay one. Yeah, it's the same. Okay, shorter side of the battery, it's negative. Longer side of the battery, it's positive. Yeah, so you must know the terminal. Okay, how to get the terminal by looking at the battery. Yeah, so after we know the terminal for the battery. So now we need to identify, okay, the next thing we must be able to identify the ions, okay, what kind of ions, okay, that is present, okay, what kind of ions, okay, that is present in your electrolyte, okay. So what ion we have inside the electrolyte, okay. Example, let's say we have this. So this is your electrolyte, okay, this is the electrolyte, and this electrolyte is molten. This electrolyte is molten zinc oxide, okay. So you must know inside the molten zinc oxide what is the ions that you have. Ion means the charge. So zinc ion, you have zinc, molten zinc oxide, you have zinc. Zinc is Zn2 plus. Zinc is Zn2 plus. Oxide, it's O2 minus. Okay, oxide is O2 minus. So we have Zn2 plus and O2 minus inside the molten zinc oxide. So same thing, one more diagram. So let's say here we have another crucible, and then we have another electrolyte. Now this electrolyte is called molten, let's say lead 2 bromide. Okay, molten lead 2 bromide. So for molten lead 2 bromide, what are the ions that we have? Okay, what are the ions that we have? So in molten lead bromide, the ions we have is lead. So lead is Pb2 plus. So we have Pb2 plus. We also have bromide. Bromide is Br minus. Okay, so we must able to know what ion we have. What ion we have inside the electrolyte. Okay, so after we know which ion we have in the electrolyte, the next thing that we need to learn is this. Okay, the next thing, now we need to learn where the ion will go. Okay, where the ion will go. Okay, so where the ions will go. Okay, so where the ions will go. So ion, they have charge. All the ion have charge. And we learned before, same charge repel, opposite charge attract. So we learned that, okay, opposite charge will actually attract. So, which means this, okay, opposite charge, okay, they attract. Okay, so let's say today we have battery and we have wire, and the wire here we connect to 2 pieces of electrode. So this is electrode. Okay, so now you can see longer side of the battery, it's positive. Shorter side of the battery, it's negative. Okay, so when this electrode connect to the positive side of the battery, this is positive electrode. Okay, when this electrode connect to the negative side of the battery, so this electrode is negative electrode. Okay, all right, so this is quite simple. So positive electrode will attract negative ion. Okay, so cannot be positive, right? Because if positive and positive ion, they will repel. Okay, so positive electrode will attract negative ion. So you will see negative ion like this, negative ion, negative ion, negative ion. They were all attracted to positive electrode. Okay, okay, so negative ion, we call it as anion. Okay, so negative electrode will attract positive ion. So positive ion will come here, positive ion come here, positive ion come here. Okay, so positive ion will be attracted to negative electrode. Yeah, positive ion we learn in form 4 is called cation. Yeah, all right, so very simple. Negative ion will move to positive electrode, positive ion will move to negative electrode. That's it. Okay, opposite charge attract. Yeah, so now after the ion go to anode and cathode, now this is the most important thing, step number 4. So step number 4 is very important. So I'm going to put 3 stars here. Very important. Very, very important. So you must know, okay, all the ion move to anode and cathode not for fun. Okay, so all the ion, they go to anode, they go to cathode not for fun. They go to positive and negative terminal not for fun. They go there for a reason. Okay, so all the ions that actually move to positive or negative terminal. Okay, all ion they go to positive or negative terminal for one reason only. Okay, because the ions they want to be, learn this word, discharge. All the ion go to anode and cathode because they want to be discharged. Okay, discharge in BM, discharge, they call it as near, N-Y-A-H, near. Okay, they call it as near charge. Okay, in BM, they call it as near charge. Okay, so if you learn in BM, this is the words that you must know. Okay, so what do we mean by discharge? Okay, what do we mean by discharge? Okay, so discharge means that they want to throw away the charge to be neutral. Okay, so here let me write a side notes. Okay, I write a notes on the side here. So what do we mean by discharge? Okay, so the word discharge means that they want to throw away the charge. Okay, all the ion want to throw away the charge, and then they want to be neutral. Okay, all the ion they want to throw the charge away, and then they want to be neutral. So this is what we call discharge. Okay, so remember, all the ion they go to anode, they go to positive and negative terminal because they want to be discharged. Okay, so let me give you some example. Okay, let me give you some example. Let's say Cl minus ion, okay, will Cl minus ion want to discharge. So when Cl minus ion throw the charge away, it become neutral Cl. So when Cl in a neutral form, we always have it in Cl2. Yeah, we never see Cl like this one. Cl if neutral, it must be Cl2. So same thing, if today we have oxide O2 minus. O2 minus after discharge, after you throw the charge away, you get O. But we never see O in a neutral form. Neutral form, the O will be in O2. Okay, that's it. So one more, let's say Na plus. So if the sodium ion, okay, they go to the electrode, they want to discharge. So when sodium ion throw the charge away, it become neutral Na. So last one, let's say aluminium, Al3 plus. So aluminium ion go to the electrode, again, not go there for fun, Okay, so aluminium ion go there because aluminium ion want to discharge. So when we throw away the charge from aluminium ion, it become neutral Al. Okay, so that's it. So this is a very important concept that you must know. All the ion, they go to anode, they go to cathode, they go to positive terminal, they go to negative terminal because they want to discharge. They want to throw away their charge. Okay, so this is a very important concept that you need to know in electrolysis. So next one, almost done already. Step number 5. So we can write the half equation. Okay, so we will be able to, we want to write half equation. So I mentioned many times already, half equation is the most important thing in this chapter. Okay, half equation is the most important thing in this chapter. Yeah, all right. So after we have the half equation, so you can use the half equation to do your apple to apple comparison, the oxidation, the reduction thing, and you also can use the half equation to get observation. So you can use the half equation. Okay, you can use the half equation to do your apple to apple comparison. Okay, you can do apple to apple comparison. So I assume all of you should know what is apple to apple comparison, because we do it for so many times already. And you can use the half equation to get observation. Okay, you can use the half equation to tell people what you can see. Yeah, what you can see, that is observation. Okay, all right. So that is the 6-step process. This is the 6 steps process. How are we going to do our electrolysis? Okay, so in a short while I'll use some example. I'll use some example to demonstrate. So when we use example to demonstrate, you will understand better. Yeah, you will understand better. So for now, just fully understand the 6 steps first. Okay, the step by step what we can do first. Okay, so I'll teach you one more thing before we start with example. I'll teach you one more concept before we start with some example. Okay, all right. So now, okay, I want you to know some of the common observation in electrolysis. So this is some common observation, okay, in electrolysis, or you can call electrolytic cell. Okay, you can call it electrolysis or you can call it electrolytic cell. Okay, in electrolysis, okay, always remember, if you want to get the observation, always refer to half equation. Always refer to half equation if you want to get observation. Okay, all right. So when you come to electrolysis, what you need to do? Okay, so in your electrolysis, okay, in your electrolysis, if you refer to the half equation, if you notice that the final product, okay, the final product, if the final product is a metal, okay, if your final product you get a metal, okay, we will be able to see a solid. You can see solid. Okay, let's say your final product is aluminium, you will see solid. Your final product is zinc, you will see a solid. Yeah, if the final product is metal, you will see solid. If the final product it is a non-metal, okay, in electrolysis, if the final product is non-metal, you will see gas. Okay, we will see a gas. Okay, let's say if the final product is chlorine, chlorine is non-metal, you will see a gas. If the final product is oxygen, oxygen is non-metal, you will see a gas. Okay, that's it. Okay, so by knowing the final product is solid or is metal or non-metal, then we will know whether we will see a solid or we will see a gas. Okay, all right, so this is something. Okay, so I'll give you some common product that you will see in the electrolysis, and then the observation. Okay, this is the product and this is the observation. Okay, so your final product, you don't, this table don't need to memorize. I just show you only, no need to memorize. Chlorine, bromine, iodine, oxygen and hydrogen. So no need to purposely memorize. Okay, so chlorine, bromine, iodine, oxygen and hydrogen. Okay, so all of them, they are non-metals. Okay, chlorine, bromine, iodine, oxygen and hydrogen, they are non-metal. So when they are non-metal, you should expect to see gas. Okay, you should expect to see gas, because non-metal you will get a gas. Okay, this is for electrolysis. Okay, so what about the color? Okay, what about the color? Okay, chlorine gas, okay, chlorine gas, the color is greenish yellow. Okay, chlorine, the color is greenish yellow. Okay, it's a greenish yellow gas. Okay, here there are some students, they mess up already, because they say, sir, I thought chlorine is pale yellow. Okay, I thought chlorine is pale yellow. So here you have to be very, very careful. Okay, so don't mess up like this. So this is a very important reminder. Okay, this is a very important reminder for you. Okay, so you have to be careful with chlorine, bromine and iodine. Okay, this is when they are in liquid form or solution form. So when chlorine, bromine and iodine in solution or in aqueous form, the color is this. Chlorine in a solution form, we call chlorine water, that we learned before. Chlorine water is pale yellow. Bromine in the solution form, okay, when we have bromine in the solution form like bromine water, so the color is brown. When iodine is in the solution form. When we take iodine, we dissolve the iodine in water. When the iodine in a solution form, it is brown color. Yeah, we learn this in halide displacement. Yeah, we learn this in halide displacement before. Yeah, so the color pale yellow and brown. Yeah, we learn this. Okay, this is when they are in solution form. But now in electrolysis, okay, electrolysis, the non-metal we will see gas. So for electrolysis, we will not see solution form. Okay, we won't see solution form. We will see it in a gas form. Okay, it will be in a gas form. So in gas form, chlorine is greenish yellow. So in gas form, the chlorine is green color mixed yellow color. Greenish yellow. Okay, greenish yellow. Okay, so if you learn in BM, you have to be careful. If BM, they will mention the yellow first. They will write kuning kehijauan. Kuning kehijauan. In BM, they will write the yellow first. Kuning kehijauan. In English, we write the green color first. Greenish yellow. Okay, so bromine is a non-metal. You will see a gas. Bromine in the gas form is brown color. So it's a brown color gas. Okay, so here bromine in the gas form, it's brown. Okay, iodine. Iodine, it's a non-metal. So you will see a gas. Iodine in the gas form is purple color. Iodine in the gas form is purple color. So purple gas. Okay, so iodine is purple gas. So you have to be very careful. Iodine in the solution form is brown. Okay, iodine in the gas form, it's purple. So all this color is very important. So remember, if you're having a hard time to memorize, take a piece of paper, copy for a few times. Yeah, take a piece of paper, copy for a few times. That will help you a lot in memorizing. Okay, okay, next one. Okay, oxygen and hydrogen, they are non-metal. They are gas. So what is the color for oxygen and hydrogen? Oxygen and hydrogen, both of them, they are colorless. Oxygen don't have color. Hydrogen don't have color. So they are colorless gas. So we cannot see colorless gas at all. So in reality, in your experiment, when we do the experiment, if there is colorless gas, you cannot see one. You cannot see. For example, this is a beaker. If inside here got colorless gas, you cannot see one. So for colorless gas, you only can see if there is bubbles. If we have bubbles, then we know there is colorless gas. Okay, so if we have colorless gas, you will see some bubble here. You will see bubbles. So colorless gas, you need to write the word bubble. Okay, for all the gas which got color, this one, the gas got color, you don't need to write the word bubble. No need. Because if the gas got color, you can see the color easily. Okay, you can see it easily. So you don't need to write the word color. But if the gas is colorless, you cannot see. If the gas is colorless, you cannot see. So you need to see bubble. Then only you know there is colorless gas. Okay, so please be very careful on this. Okay, now we have the non-metals. So what about metals? Okay, so if your final product is metal, so what you can see, so if your product is metal, so all the metals that we have except copper, so except copper, Cu. So all metals, okay, such as aluminium, zinc, magnesium, all metals, you will see solid. All the metals, they are in solid form. And the color is gray color. Okay, all the metals, they'll be gray color solid. Example, magnesium is a metal, gray solid. Aluminium is a metal, gray solid. Yeah, okay, so the only special metal you need to know is copper. Okay, copper is also a metal, so you will see a solid. Okay, copper is also a metal, so you can see a solid. But copper is not gray color. Copper is not gray color. Copper is brown color. Okay, copper is brown color. That's it. So whenever you have a copper metal, you will see brown color solid. Okay, that's it. So these are some very common observation that you need to know when you come to electrolysis. So in electrolysis, let's say we will learn this later. Let's say in electrolysis, you will get this half equation. 2Cl minus becomes Cl2 plus 2E. Then you know already. Since your final product is a chlorine, you will see greenish yellow gas. Okay, chlorine is a non-metal, you see gas. The color is greenish yellow. Let's say your final product is this. Okay, Al3 plus 3E become Al. Okay, since your final product is aluminium, aluminium is a metal. So when aluminium is a metal, you should expect to see a solid. So what is the color for aluminium? So all the metals, they are gray. So you will be able to see a gray solid. Okay, that's it. Okay, you can refer to the half equation to get your observation, and these are the common observation you will get in electrolysis. So in electrolysis, if the final product you get is metal, you will see some solid. If the final product is non-metal, you will see a gas. And make sure you know the color. And one very important thing that I say just now, don't mess up the color of halogen with the halide displacement. So when we learn halide displacement, when we learn U-tube, these halogen, they are in solution form. Yeah, when we learn U-tube, when we learn halide displacement, the halogen is in solution form. Okay, like this. Okay, so today if we add in, okay, bromine water, so bromine water, so the bromine is in liquid form, so it's brown. Okay, so let's say today we have iodine water. Okay, if we add in iodine water, so iodine water, the iodine is in liquid form. In liquid form, iodine is brown. Okay, but today if we have a gas like this, okay, this is a gas. This is iodine gas. So if iodine gas, you will see purple. Okay, so the color, you have to be very, very careful, because many students, they mess up the color with halide displacement. Yeah, they know the color, but they confuse and they mess up the color with the colors they learned back in the metal displacement. Okay, so this is something that you have to be very careful. Yeah, so let me put it in a box. Okay, all right, so please be very careful with the color, yeah, of the halogen. Okay, whether the halogen is in solution form or whether the halogen it is in gas form. Yeah, the color is different. Okay, so don't mess up and don't confuse on this. Okay guys, I will use a few examples to cover the electrolysis of molten. Alright, so we'll try to do a few examples to cover all this strategy. Okay, so let me start with the first example here. Okay, so this is the first example. Okay, so example number 1. Okay, so for example number 1, okay, so we will have this diagram. Okay, let me write it first. Okay, so we have battery, we have wire, we have 2 pieces of electrodes. Okay, we have 2 pieces of electrode. Okay, then we have a crucible. So after the crucible, we have a liquid. Okay, then here we have our electrolyte. So our electrolyte is molten sodium chloride. Okay, so we have molten sodium chloride here. After that, we need to heat the substance. Okay, we heat the substance to melt it. Okay, okay, so this is the first example. Okay, so let me show you step by step how to use the strategy to solve the question. How to use the strategy to solve a question. Okay, so look at the step number 1. So step number 1, we need to label positive and negative terminal. Okay, refer to the battery. Okay, so by referring to the battery, the longer side of the battery is positive. Okay, so this is positive. The shorter side of the battery, so this is negative. Okay, so now we already label the positive and negative terminal. Okay, so let's look at step number 2. Step number 2, we need to identify the ion that is present in the electrolyte. So we need to know what kind of ion that we have, what ion we have. Okay, so let's look at the electrolyte. So our electrolyte is molten sodium chloride. So molten sodium chloride, the ions that is present, okay, so the ions that is present, okay, has 2. So the first ion is sodium. Sodium is Na plus. The second ion is chloride. Chloride is Cl minus. Okay, so we have 2 ions inside the liquid. Okay, so what is the third step that we should do? The third step, we should know where the ion will go. Where the ion will go. So ion, they will go to opposite charge electrode. Opposite charge attract. So let's look at the charge here. Positive electrode will attract opposite charge negative ion. So the Cl minus will come over. Cl minus will come over. Yeah. Then negative electrode will attract positive ion. Yeah. Negative electrode will attract positive ion. So Na plus will come over. Na plus will come over. Yeah. So now we already know where the ion will go. Okay, so what is the next step? Okay, look at step number 4. Step number 4 is a very important step. All the ion, they move to positive and negative terminal because they want to be discharged. So now we know the ion want to be discharged. Okay, and we need to write the half equation. Okay, so this step is a bit technical, so we have to be more careful. This step is a bit more technical, we have to be more careful. Okay, so now we start with this positive terminal. So here we can start with positive terminal first. Okay, positive terminal. Okay, so at positive terminal here, who come over? Cl minus. You can refer to the picture. This diagram can help you to see the whole thing. So for positive terminal, Cl minus come over. So Cl minus come over. So Cl minus come over for what purpose? So remember, all the ion, they go anode and cathode. They not go there for fun. They not go there for fun. They go there because they want to be discharged. All the ion, they want to be discharged. Discharge means that they want to be neutral. Okay, they want to throw the charge to be neutral. So Cl minus, if you throw the charge away, you will get neutral Cl. So Cl, when it's neutral, it's appear in Cl2. Okay, remember, Cl, when only have 2 possibility, if you got charge, is Cl minus. If neutral, Cl2. Okay, that's it. So Cl minus will become neutral Cl2. So then we will finish off this half equation. Half equation, we need to balance it. 2 Cl on the right, we put 2 Cl on the left. After that, remember, half equation, we need electron. The number of electron is decided by total charge. The number of electron is decided by total charge, not the oxidation number. Okay, to know how many electron, we need to know the total charge. Left hand side, total charge, the total is -1 times 2. So it's -2. So left hand side, the total charge is -2. Right hand side, we don't see any charge, 0. So -2 and 0, so the charge differ by 2. So the difference of the charge is 2. So we need to use 2 electron. So always remember, put the 2 electron to the more positive side. Always put the electron to the more positive side. Okay, so by doing that, so we have successfully write the first half equation. Okay, so let's try to write another half equation. So let's go to another terminal. So now we go to negative terminal. Okay, so we go to negative terminal. Okay, so let's go to negative terminal. So for negative terminal, which ion go over? Look at the picture. So negative terminal, sodium ion come over. So Na plus go to the negative terminal. You can look at the picture. Yeah. That's why when you come to electrolysis, it's highly advisable for you to draw the picture, because when you draw the picture, you can see what is happening. Yeah, you can see what is happening. Okay, so as you can see, negative terminal attract positive ion, sodium. So sodium ion go to negative terminal. What is the purpose? So the purpose is the same. All the ion, they go anode, they go cathode, because they want to be discharge. All ion want to be discharged. They want to be neutral. So sodium ion, if you throw the charge, it become neutral sodium. So balance the quantity on the left and right. Okay. So then we balance the charge. So the number of electron decided by total charge. So the total charge on the left hand side is +1. The total charge on the right hand side is 0. +1 and 0, the charge difference is 1. When the charge difference is 1, we need 1 electron. And put the electron to the more positive side, which is the left hand side. I hope everyone understand how to get the half equation here. Yeah, because we learn this, we learn how to write half equation for many lessons already. Okay, I really hope everyone know how to get the half equation. Okay, so by doing that, now we have successfully get the half equation already. Okay, lastly, now we can use the half equation to get observation. Yeah, we will get our observation. Apple to apple comparison, I don't need to explain, it's the same thing lah. You look at the half equation, then you will know you lose electron or gain electron. Then you know whether you undergo oxidation or reduction process, and whether you are oxidizing agent or reducing agent. So this is something that we do many times already. So I won't discuss it in this lesson. So we will go directly to the observation. Okay, so let's go for the observation here. Okay, so now, okay, observation. Okay, observation. So for observation, always refer to the half equation. For observation, always refer to the half equation. Okay, so let's look at the observation. Okay, observation. Okay, so what is the observation? Okay, so observation, make it a habit, always refer to your half equation. Okay, so here we have two half equation, so you should expect we have minimum 2 observation. Okay, so let's look at the first observation here. Okay, so the first observation, what we can see. Okay, so look at the product. Okay, so our first half equation, the product is Cl2, chlorine. So chlorine is a non-metal. So I say just now, when we have non-metal, we will see a gas. So chlorine will appear as a gas. So we will see a gas. So what is the color for chlorine? Remember, it's not pale yellow. It's not pale yellow. You only get pale yellow if the chlorine is in aqueous form. You get pale yellow if the chlorine is in aqueous or solution form. But now the chlorine, it is in gas form. Now the chlorine, it is in gas form. So when chlorine in gas form, the color is greenish yellow. Okay, so the color is greenish yellow. So your observation, you should write greenish yellow gas. Greenish yellow gas. And when we have a gas, use the word release. Okay, use the word release. Okay, so this is something very important. So when you see greenish, when we have a gas, when we produce a gas, okay, we try to use the word release. Okay, release. Okay, some of the books, they use the word produce. It's not advisable to use the word produce. Okay, use the word release better. So when we have a gas, better you mention the gas is being released. So when you do the experiment, you will see, okay, over here, some green color gas will come out. Okay, some green color gas will come out. So the green color gas is chlorine. Okay, so that is the observation. Observation number 2. Observation number 2, okay, look at the next half equation. So now we have another half equation here. So another half equation now we have is this. So for negative terminal, what is the final product? The final product, it is sodium. So sodium, it is a metal. Sodium is a metal. So when we have a metal, our product is metal, we will see solid. Okay, when we have metal, we were able to see solid. So our observation is solid. Okay, what is the color for the solid? Okay, so remember, sodium is a metal. So most of the metal, the color is gray. Most of the metal, the color is gray. Unless it's copper. Copper, the color is brown. For most of other metal like sodium, magnesium, zinc, aluminium, most of the metal, the color is gray. So you will see gray solid. You will see gray solid. Okay. So gray solid. Okay. If we form solid, better you use the word deposited. Okay. If your product is solid, better you use the word deposited. Deposited means sticking. So you will see at here, some gray solid will stick to here. Okay, some gray solid will stick to here. Okay, this gray solid is sodium. Okay, so use the word deposited. Okay, so it's not advisable you use the word form. Okay, so the word form, some of the book they write the word form. Even your textbook might write the word form, but it's not advisable. Okay, so here I want to put a remarks here. So the word deposited is a better. Yeah, so this is a better term. So use the word deposited is better. The word form, not advisable to use. Okay, it's not advisable for you to use the word form. Okay, sometimes in marking scheme they don't allow you to use the word form. So use the word deposited is better. So here you have to be careful. So if you produce a gas, use the word release. If you produce a solid, use the word deposited. Yeah. So this is something that you have to be very, very careful. Yeah. This is something that you have to be very, very careful. Okay. Done. Okay. So we are all done with this. Okay. So before we move on to the next example, so I want you to, we can do another one more thing here. Okay, we can do another one more thing here. Okay, we also can do the Ionic equation. Okay, we also can do your Ionic equation. So this is not very hard. We learned before. Ionic equation, we can do it by combine two half equations. Okay, so when we combine two half equations together, then we will get our Ionic equations. Okay, so this is very simple. So the first half equation is here. 2Cl minus become Cl2 plus 2E. This is the first half equation. The next half equation we have is Na plus E become Na. So remember, if we want to combine two half equation, the number of electrons must be the same. The number of electrons must be the same. So the first half equation got 2 electrons. The second half equation got 1 electron only. So cannot combine. So the second half equation, everything need to multiply by 2. Then only the electron is the same. So when they have same number of electrons, you can cut it up. Then when you combine it, you will get 2Na plus, you will get 2Cl minus. Okay, and you will get 2Na and you get Cl2. So this is your Ionic equation. Okay, so we learned this for quite some time already. Yeah, when we have half equation, we can combine the half equation together to get the Ionic equation. Okay, so now you can see this is exactly what electrolysis do. So you can see initially you have sodium chloride. Initially you have sodium chloride. But what is your final product now? Okay, you can look at what is your final product now. Okay, so if you look at the final product, so your final product you will get is this. The first final product you have, it's here, Cl2, chlorine. So the first final product you have, it's chlorine, Cl2. Okay, you can call it chlorine molecules. You also can call it as chlorine gas. No problem. Yeah. The second product that you have is Na. Na is sodium. Okay, you can call it as sodium atom, or you can call it as sodium metal also can. Yeah, so now you can see initially you have sodium chloride. Now the sodium chloride split to sodium and split to chlorine, okay, which is the two final product you have, chlorine and sodium. So this is exactly what electrolysis do. Electrolysis used to break down substance. Electrolysis, we use electric to break down the substance. So the sodium chloride, we break it down to form sodium and chlorine. So this is what we do with electrolysis. Okay, this is what we do with electrolysis. We use electric to break down the substance. Okay, so here I put the remarks. Okay, so this is what? So this is what electrolysis all about. Okay, this is what electrolysis all about. We break down the compound. Okay, we break down compound by using electricity. Yeah, we use electric to break down the substance. Okay, so this is electrolysis. Okay, so the last thing that we need to learn, before we move on to another example, the last thing that we need to learn here is what? Okay, sometimes they will ask us to label anode and cathode. Okay, sometimes they will ask us to label anode and cathode. Okay, so you need to watch out this. Okay, this is where a lot of students always do mistakes. Okay, so now look at here. So this is Voltaic Cell that we learned previously, and this is Electrolytic Cell, or we call electrolysis, that we learned today. Yeah, so you have to be very, very careful. Voltaic Cell and Electrolytic Cell, both of them, they have negative terminal, and both of them, they have positive terminal. Okay, they have negative terminal and they have positive terminal. Okay, and you have to be careful because sometimes they don't want us to use positive and negative terminal. They want us to use anode and cathode. Okay, so in Voltaic Cell, negative terminal is anode, positive terminal is cathode. This is Voltaic Cell. Electrolytic Cell, everything terbalik. Always remember, electrolytic cell is totally terbalik as Voltaic Cell. Why? Voltaic Cell produce electric. Voltaic Cell produce electric. Electrolytic Cell use electric to break down compound. Okay, so they are totally terbalik. Voltaic Cell produce or generate electricity. Electrolytic Cell use the electricity, to break down compound. So everything terbalik. So in Voltaic Cell, negative terminal is anode, but in electrolytic cell, negative terminal is cathode. Okay, positive terminal is anode. Okay, all right. So this is the one. So many students will always make a mistake here. Many students, they always confused by anode and cathode when you come to electrolysis and Voltaic Cell. So they are very blur. They don't know in what situation negative terminal is anode, in what situation negative terminal is cathode. Okay, so how are we going to use a way how to differentiate them? Okay, how are we going to differentiate them? Okay, so there are two different ways. There are two ways for us to decide anode and cathode here. Okay, I'll teach you two methods. The first method is this. Okay, the first method is we can refer to the half equation. Okay, the first method is we refer to the half equation. So method 1, okay, we can just refer to the half equation. Okay, we refer to the half equation. Okay, so now you can see just now on your positive terminal. Okay, let me copy this. Okay, we copy this one, and I'll show you how to decide anode and cathode using a simple idea. Okay, So this is 1. Okay, so we refer to the half equation and we see whether it's donate or receive electron. So as you can see, the first half equation electron is on the right hand side. So the electron on the right hand side means donate electron. Yeah. So the second half equation, the electron on the left hand side. So electron on the left hand side means receive electron. Okay, so remember the location of electron will tell you whether it's donate or receive electron. So once you know it's donate or receive electron, how to relate with anode or cathode. Okay, so remember something that we learned before in Voltaic Cell. So anode. So anode, A stand for aku, D stand for donate, E stand for electron. Aku donate electron. So anyone who donate electron, it's anode. So anyone who donate electron is anode. So you can see, since you donate electron at positive terminal, your positive terminal will be anode now. Okay. So what about negative terminal? So negative terminal receive electron. So receive electron, it's cathode. Why? Cathode, we learned before, cathode, C stand for cannot. C stand for cannot, D is donate, E is electron. So cathode cannot donate electron. Cannot donate means what? Cannot donate means receive. Cannot donate means receive. Yeah. So cathode always receive electron. So since you see at negative terminal, they receive electron. So your negative terminal, it is cathode. So this is how we decide. So you can see, make sense what? Positive terminal, anode. So look at your electrolytic cell. Positive terminal, anode. Yeah. Negative terminal, cathode. So negative terminal, cathode. Okay. So this is how we decide anode and cathode. Okay. You write the half equation first. From the half equation, you go to see whether they donate or receive electron. If they donate electron, then it's anode. If they receive electron, then it is cathode. Okay. So this is one of the way. This is one of the way. So from here now, you can label already. So the positive terminal is anode. The negative terminal is cathode. Yeah, done. Okay, so this is how we label anode and cathode. So positive terminal here is anode. Negative terminal here is cathode. Okay, so please be careful because so many students, they are so blurred, they're so confused with anode and cathode. All right, so if let's say you cannot differentiate anode and cathode, you will have a big problem. Okay, so this is method number 1. Refer to the half equation. Okay, so if you don't want to use method number 1, okay, we also can go for method number 2. So method number 2, I teach you a very simple shortcut. Okay, method number 2. Okay, so we use a concept called VAN, van. Okay, VAN, van. Okay, what do we mean by van? Okay, so let me teach you how to use van to decide. VAN, van. All right. So van stand for this. VAN. V stand for Voltaic Cell. V stand for Voltaic Cell. A stand for anode. N stand for negative. Negative terminal. So you see, this is how we memorize it. Very simple one. Okay. In Voltaic Cell, anode, it's negative terminal. In Voltaic Cell, anode is negative terminal. So then the rest you can agak-agak predict already. So your cathode will be your positive terminal. Okay, your cathode now is positive terminal. Okay, this is for Voltaic Cell. So when we have electrolytic cell, everything terbalik. So electrolytic cell, terbalik. So electrolytic cell, the anode we copy back. Just now the anode is negative terminal. Now anode is positive. Just now the cathode is positive. Now the cathode is negative. So this is how you remember. So you don't need to remember 4 things, you know. You don't need to remember here. Number 1, number 2, number 3, number 4. you don't need to memorize 4 things. No need. You only memorize one thing only. You just memorize one thing. VAN. In Voltaic Cell, the anode is negative terminal. In Voltaic Cell, the anode is negative terminal. So from there, you will know already. The cathode will be positive terminal. Okay. Anode is negative. Cathode is positive. This is for Voltaic Cell. Then for electrolysis, terbalik loh. Electrolysis, anode will become positive, cathode will become negative. Yeah. So we just use VAN and we can predict the rest already. Yeah. We can use this to predict the rest. Okay. This is how it works. Okay. So learn smart. You don't memorize everything, because if you memorize everything, it's very, very confusing one. Yeah. It's very, very confusing if you go and memorize every single thing. Okay. So this is for example number 1. Okay, let's try to do example number 2. Okay, so I'll try to do example number 2 with you all. Okay. Okay, we try to do it one more time. Okay, hopefully example number 2 you see a better idea. Okay. So let's see. Okay, just now we have example number 1 already. So let's go for example number 2. Okay. All right. So let me write here. Example number 2. So example number 2. Okay. So for example number 2, so I will change the electrolyte. Okay. So now for the electrolyte, I will change a bit. So now I don't use molten sodium chloride. Okay. Let me use another one. Yeah. Let me use another one. Okay. So now I will use molten. Maybe I use molten lead, L-E-A-D, lead. 2. Then I go for bromide. Okay, molten lead 2 bromide. Okay, molten lead 2 bromide. Okay, now let's do the same thing again. So first of all, you can refer to the strategy. Strategy, first of all, we need to decide the terminal first. Okay, we need to decide the positive and negative terminal first. So longer side, okay, the longer side here it's positive terminal. Okay, longer side you can check. Okay, longer side is positive terminal. Okay, so it's positive. Shorter side it's negative. Okay, long is positive, short is negative. Okay, so positive terminal also can call anode, negative terminal it's called cathode. So remember, if it's very, very hard for you to memorize, you can do it in this way. Okay, you can do it in this way. Okay, all right. Always how to do it. Okay, so you can see VAN. So VAN, V is Voltaic Cell. So Voltaic Cell, A is anode, N is negative terminal. So how to use this to predict the Voltaic Cell? Okay, so then we go the other way around. Okay, so Voltaic Cell, anode is negative terminal, cathode it's positive terminal. So when we have electrolysis, everything terbalik. Electrolysis, so the anode copy back. Just now anode is negative, now become positive. Cathode copy back. Just now the cathode is positive, now is negative. Okay, use VAN to memorize. Okay, so you can see anode is positive, cathode is negative. So that's why anode is positive, cathode is negative. Yeah, so you must be able to label your anode and cathode correctly. Okay, you need to be able to label your anode and cathode correctly. It's very, very important. Okay, so step number 1, we label positive and negative terminal, anode and cathode. Step number 2, we must identify the ion that is present. So what ion we have? So lead bromide, we have lead. So lead is Pb2+. So we also have bromide. Bromide is Br-. Okay, so we have Pb2+ and Br-. Okay, so now we already know what ion inside here. So next one, step number 3, we need to know where the ion will go. Okay, where the ion will go. Positive electrode attract negative ion. So bromide ion is negative, they will go to positive electrode. Negative attract to positive. So negative electrode attract positive ion. Pb2 plus will come over, Pb2 plus, they will come over. Yeah. Alright, so now we already know where the ion is going. Next one, we need to know why they go to anode and cathode. All the ion go to anode and cathode for one purpose only. They want to be discharged. Okay, all the ion, they want to be discharged. They want to be neutral. So let's start with anode. Okay, so we start with the anode first. So on the anode here, as you can see in the half equation, who come to anode? Br minus. So Br minus come to anode because it want to be discharged. So when Br minus, you throw the charge away, it become neutral Br. Okay, now we get a neutral Br. So Br, when it's neutral, it always appear in Br2. Okay, when Br is neutral, it always appear in Br2. Okay, because we only have two form of Br. If the Br got charged, is Br minus. If the Br is neutral, Br2. Okay, that's it. Okay, now we need to balance the equation. Put a 2 to balance it. So the total charge on the left hand side, negative 1 times 2. So it's negative 2. Total charge on the right hand side, 0. So negative 2 and 0, the total charge difference by 2. So when the difference is 2, we need 2 electrons. Put the 2 electrons to the more positive side. So then we get the first half equation already. Yeah. So now we will do the same thing. We will write the half equation for cathode. Okay. Now we will write the half equation for the cathode. So now look at the picture. Look at the diagram. So who come to cathode? Okay. As you can see in the picture, Pb2 plus come to the cathode. Pb2 plus come to the cathode. So Pb2 plus come to the cathode. So when Pb2 plus come to the cathode, what they want to do? Discharge. All the ion want to discharge. Discharge means they want to be neutral. So when Pb2 plus throw the charge away, it become neutral, Pb. So we balance the Pb. We have one Pb on the left, one Pb on the right is balanced. Total charge on the left is plus 2, on the right is 0. Plus 2 and 0. The charge difference by 2, we need 2 electrons. Put the 2 electrons to the more positive side. By doing that, now we already get our half equation. Yeah? So now once we have the half equation already, we can use the half equation to get observation. Okay, we can use the half equation to get our observation. So remember, observation always refer to the half equation. Always refer to the half equation. So what is the first observation? So the first observation here is this. Since our product is bromine, so at anode we produce bromine. So when we produce bromine at the anode, okay, so what we can see, bromine is a non-metal. So bromine, it is a non-metal. So for non-metal, you will see a gas. What is the color for bromine? Bromine is brown. So you will see brown color gas. So when we have gas, use the word release. Okay, when we have gas, use the word release. Brown gas is released. Okay, if you want to be more accurate, you can say brown gas is released at anode. Okay, brown gas is released at anode. So this is more detail. But in exam, even you don't write at anode is okay. You just write brown gas is released. That's good enough. So look at the second half equation. So now we go for another observation. So we refer to another half equation. So this half equation, what is the final product? The final product is Pb. So Pb is lead. Lead is a metal. Okay, lead is a metal. So when we produce a metal, you expect to see a solid. Okay, when we produce a metal, you will see a solid. Non-metal, you see a gas. So what is the color for lead? Lead is gray color. Okay, all the metal, they are gray except copper. So copper, it's brown. So you will see gray solid. Okay, the gray solid, it's okay, don't use the word form. Solid, use the word deposited. Okay, use the word deposited, don't use the word form if possible. So gray solid is deposited at cathode. Okay, so you can see at cathode you produce a metal, so you see gray solid. Okay, but again, in exam, if you don't write at cathode, you only write gray solid is deposited, it's okay, you will still get your full mark. Okay, so you see, not very hard. Once you have half equation, observation, it's very simple. Yeah, when you have half equation, the observation, it's very simple. Yeah, so this is what we are doing. Okay, step by step. Okay, step by step. All right, so it's not too hard. If it's not too hard, if you follow step by step, okay, everything will be okay. Everything will be okay if you follow all the steps. Okay, so now in this case, okay, can we get our Ionic equation? Yes. Okay, so we still can get our Ionic equation. So to get Ionic equation, we combine two half equation. So the first half equation, we copied it. Okay, it is 2Br minus become Br2 plus 2E. The second one is Pb2 plus 2E become Pb. So to combine the half equation, the electron must be the same. So now both of them got 2 electrons. We can combine directly. Cut the electron away. When we combine it, Pb2 plus 2Br minus to become Pb and Br2. Okay, so by doing that, we already get the Ionic equation. Okay, so they might also ask us, what is the final product? Okay, what is your final product? So same thing, look at the half equation. So at anode, your product is Br2. At anode, your final product is Br2. So it is bromine. Okay, you can call it a bromine molecule because it is a molecule, bromine, or you can call it a bromine gas. So the second product you have is this. The second product you have is Pb. Okay, so Pb is lead. Okay, Pb is lead. Some people pronounce as lead. It's okay. So we have lead. So you can call it a lead, or you can call it lead atom. Okay, because the Pb is alone, you can use the word atom. Lead atom, or you can call a lead metal. Yeah, you can call it a lead atom or lead metal, no problem. Yeah, so that's the final product. So you can see what the electrolysis do here. Electrolysis break down the lead bromide. So when lead bromide break down, you will form lead and you will form bromine. Okay, so this is what electrolysis do. Electrolysis help us to break down the compound. Yeah, electrolysis help us to break down the compound. So we break the substance to form something else. So this is what electrolysis all about. Yeah, we break down the compound. Okay, so not very hard, we just do it step by step. Yeah, so let's go on with the last example. So now we will cover example number 3. Yeah, so we already have example number 1. So and then just now we have example number 2. So let's go on with example number 3. So this will be the last example that we will cover for today. Yeah, so example number 3, same thing. So let me draw the diagram. So this is a battery. Okay, this is a battery, and then this is the wire, and then we have your electrode. Okay, so this is electrode, this is electrode. So this is the crucible. You need to use a crucible to heat the substance so it can melt. So we use a crucible because we want to heat the substance to melt the substance. Okay, we heat it. Alright, so over here, okay, let's say here we have a molten substance. This is molten copper 2 oxide. Let's say we have molten copper 2 oxide here. Okay, alright, so this is the diagram. Okay, so now as usual, so follow the strategy step by step. So this is the strategy, you can refer back. Step by step. Most importantly, no rush, step by step. Okay, Step number 1, we need to identify the terminal and anode cathode first. Longer side of the battery it's positive. Shorter side of the battery it's negative. Positive electrode, it's called anode. Okay, positive electrode, it's called anode. Negative electrode is cathode. So this is very important. Voltaic cell, terbalik. Voltaic cell is opposite. Voltaic cell, anode is negative, cathode is positive. That is voltaic cell. So please be very careful. Don't mess up. Don't mess up. You can use the VAN concept I teach you just now, okay, to memorize. So after that, we need to know what ion is present in the electrolyte. Okay, so what is the ion that is present? So in the electrolyte, what we have? We have copper 2. Copper 2 is Cu2+. We have oxide. Oxide is O2-. Okay, so we have Cu2+ and O2- in the liquid here. Okay, inside the liquid here, we have Cu2+ and O2-. So now we need to know where the ion will go. So where the ion will go? Ion always go to opposite charge electrode. Positive ion will go to negative electrode. So Cu2+ will come here. Cu2+ will come here. Yeah. So after that, negative ion will go to positive electrode. So O2- will come over. O2- will come over. Yeah. So make good use of the diagram, because when you have the diagram, you can imagine. You can imagine what is happening. Okay. So now after we know where they go, now we need to write the half equation already. So let's start with anode. So who come to anode? O2-. So we can write this. So we start with anode. So our anode, we have O2- come over. So what is the purpose of O2- come over? So remember, in electrolysis, all the ion go to anode, go to cathode with one purpose only. All the ion, they go to anode, they go to cathode with one purpose. They want to be discharged. They want to be discharged. Discharge means they want to throw the charge away. They want to be neutral. So let us throw the charge away to become neutral. So when O2- throw the charge away, it becomes neutral, O. So we never see O come alone. So when oxygen is neutral, it's O2. When oxygen is neutral, it's O2. So now we need to balance the quantity. We have 2O on the right. We put the 2 on the left. So now the O is balanced. So now we need to check how many electrons we need. Okay, because half equation we need electron. Half equation we need electron. The number of electron decided by total charge. So total charge on the left hand side, -2 times 2. So it is -4. Total charge on the right hand side, 0. So -4 and 0, the difference is 4. Yeah, the difference is 4. We need 4 electron. Put the 4 electron to the more positive side. So by doing that, we already get the first half equation. So let's try to get the second half equation. So let's look at cathode. So same thing, look at the picture, look at the diagram. So cathode, who come to cathode? Cu2+. Cu2+ go to the cathode. So Cu2+ come to the cathode. So why the Cu2+ come to cathode? So ion go to anode and cathode because they want to be discharged. Okay, so in electrolysis, we want to discharge the ion. So Cu2+ want to discharge. So when Cu2+ throw the charge away, it becomes neutral, Cu. Okay, so now we need to check the charge. Left hand side, the total charge is +2. Right hand side, the total charge is 0. +2 and 0, the charge difference is 2. We need to put 2 electron to the more positive side. Okay, we need to put 2 electron to the more positive side. Okay, so by doing that, we already successfully get 2 half equations. So now we already have the half equation. So once we have half equation, the rest is easy. The rest is easy already. So now we can use the half equation to predict our observation. Okay, we can use the half equation to predict our observation. So let's refer to the first half equation. So the first half equation, our product is O2. Okay, our product is O2. So O2 is oxygen. So what we can see for oxygen? Oxygen is a non-metal. So non-metal, we will see a gas. Okay, non-metal, we can see a gas. So what is the color for oxygen? Oxygen don't have color, so it's colorless. So we have colorless gas. So remember, if the gas is colorless, we cannot see it. We cannot see colorless gas. So colorless gas must use bubbles, only can see. So if the gas got color, you don't need to write the word bubble, like greenish yellow gas, brown gas, that's it. But if let's say the gas got color, you must, so if the gas is colorless, then you need to put the word bubble. So same thing, if you have gas, so try to use the word release. Okay, so try to use the word release. You can use the word form, but not advisable. You can say colorless gas bubble is form, but form is not advisable because sometimes marking scheme accept it, sometimes marking scheme don't accept it. So try not to use the word form. Gas, you use the word release, is better. Okay, what about the second observation? So let's look at another half equation, the cathode. Okay, oh yeah, one more thing. You can say colorless gas bubble is released at where? So the oxygen is a colorless gas bubble is released at anode. Yeah, so you can write at anode. Okay, but the word at anode is optional. If you don't write at anode, it's okay. So the next one. Okay, what about cathode? So cathode, the final product is copper. So copper is a metal. For metal, you will see solid. Okay, for metal, you will see solid. So what is the color for copper metal? Brown. Yeah, so you will see brown solid. Okay, brown solid is solid. Always use the word deposited. Okay, solid, we use the word deposited. So brown solid is deposited. And where? So the brown solid is deposited at cathode. But same thing, if you don't write the word at cathode, is okay. If you don't write at cathode, it's still okay. You still get your full mark. So you see, when you have half equation, the observation is very, very easy. Okay, so what else we need to know? Okay, we also need to know the final product. So when we do electrolysis for copper 2 oxide, the final product is what? O2. So O2 is oxygen. So O2 is a molecule. You can write oxygen molecule or you can write oxygen gas. It's okay. So you also produce another product. So another product you form is this. Okay, another product is Cu. So Cu is called copper. So copper is alone. You can use the word atom, or else we know copper, it is a metal. So you can write copper atom or copper metal. So that is the product. Okay? Alright. So now the last thing, as usual, we can combine two half equation to get ionic equation. Yeah? So let's get our ionic equation. Okay? Let's do our ionic equation. So the first half equation is 2O2 minus to become O2 plus 4E. The second half equation is Cu2 plus 2E become Cu. So one of the equation got 4 electron, another one got only 2 electron. So when number of electron is not the same, we cannot combine. Yeah. So to combine two half equation, the number of electron must be the same. So this one got 4 electron, this one only got 2 electron. So we need to multiply everything here by 2. Okay, we need to multiply everything by 2 to make it 4 electron. So multiply 2, this is 2, and this one is 4 electron, and this is 2 copper. So now both of them have 4 electron, we can combine them. So cancel the electron away, then combine them. So when we combine, normally when we have positive and negative ion, we write the positive first. 2Cu 2 plus, and then negative 2O2 minus. So come here, 2Cu and here O2. Okay, so this is how we get our ionic equation. Yeah, we can combine two half equation together. Yeah, all right. So I think that's it. Okay, so now you can see we already get everything here. Okay, so everything start with the proper strategy. Okay, so this is what we do step by step. Okay, step number 1, label the terminal. Step number 2, we must know what ion we have. Okay, what ion we have in the electrolyte. Step number 3, we must know where the ion go. Okay, where the ion will go. Step number 4, we need to know, okay, the ion go to anode or cathode for what? For discharge. Okay, the ion go to anode and cathode because they want to discharge. Then we go to write half equation. Okay, we go to write half equation. So once we have half equation, we can use the half equation to get observation. Okay, we can use the half equation to get observation. We also can combine the half equation to get ionic equation. Yeah. So when we have half equation, everything will be easy. Okay. So this is step by step. Okay. So you can refer to here. Okay. Step by step, how are we going to solve electrolysis question? Okay. How to solve electrolysis question step by step. Okay. So I hope after these 3 examples, you have a better idea. Okay, you have a better idea what is electrolysis all about. Okay, it's not very hard, but you have to do it step by step. Yeah.